everyone, here I am with the promised video on subnetting. So welcome to our subnetting adventure. If you have ever felt intimidated by IP addresses or network segmentation, don't worry. Today I am breaking it down in a way that is simple and easy to understand. So get ready to master subnetting with plenty of fun along the way. Let's dive in without wasting time. First of all, let's try to understand what is subnetting, why do we need subnetting, and what's the process of subnetting. Subnetting is the process of dividing a large network into smaller, more manageable subnetworks known as subnets. Why do we need subnetting? We need subnetting because of the advantages that it provides us, and those advantages are performance, security, and organization by segmenting traffic and reducing congestion. Now, what is the process of subnetting? If you see, this is a default network. In a default network, we have network identifier and host identifier. But once we do subnetting, we get one more identifier, and that's subnet identifier. Where the subnet identifier came from, it came from converting some bits of host identifier into network, and that is called subnet identifier. And remember one thing, that when we do subnetting, we no longer have default subnet mask. We have a custom subnet mask that we need to find the value of that subnet mask using the binary calculator. We will see that in the next slides. But before that, let's try to understand in basic language what is subnetting. Suppose you're getting a large pizza, but a small slice of that pizza can satisfy your hunger, and the rest of that big pizza, it can go to waste because you cannot eat it. So the same way in networking, if you're using a network, a default network, it gives you either a lot of host addresses or it gives you a lot of network addresses that we cannot use in the company or organization, and the rest of those network or host addresses will go to waste. So instead of that, what we do, we use a small slice of that network, which is called subnetting. As we mentioned before, that subnetting provides us some advantages, and those are performance, security, and organization. So it provides us better performance by reducing the broadcast traffic. What is broadcast traffic? We will discuss more when we talk about switches. And it provides us better security by controlling the traffic flow between the subnets and limiting the unauthorized access to our resources. And organization, definitely when we have different networks, it makes it for the administrator to easily troubleshoot, easily find the problem, and also apply policies on each group differently or separately. So these are the subnetting rules, and these are very important. We need to make sure to understand these and apply these when we do subnetting. So first of all, the first rule is to identify the IP class. We already studied the classes, the range of IP addresses classes, how we can identify the IP class by their range. Every class of IP address, they have a specific range, so we need to find what class of IP addresses. That's simple and easy. The second rule is to identify the network and node ID. As we know that every class of IP address, they have specific network octets and network and host octets, so we need to specify and identify those. And the rule 3 is to apply default subnet mask. As we already know that every class of IP address, they have default subnet mask, and we need to apply when we are doing subnetting to make our life easier. Now, rule number 4 is to convert subnet mask to binary. We already did this in the previous classes. It's not difficult. Once again, we will do it here, and I'm sure you will easily understand it. And rule number 5 is to use the formula to the power of n-2 to determine custom subnet mask. Now, this formula helping us to find the value of the custom subnet mask, and in networking we only have one formula, and that is this one. And rule number 6 said to determine LSB. Why we need to determine the LSB? What is LSB? LSB is the smallest bit in the octet that still have value. We will see this when we are doing the calculation. It's very easy to understand, but why we need to find this, it gives us the first subnet and also the range, which is very important in subnetting. So let's see. Okay, so here I am with the actual calculation and actual explanation of subnetting, or the process of subnetting. So as you see here, this is our binary calculator. This helps us to find and calculate the custom subnet mask. Now we will once we do it, we will understand and easily get this how it works. Now this is the same thing if we just store it up, and this is another chart that helps us to understand. This is basically the value of these showing in power. Now this is the scenario. This is the network, and this is what we need. We need 11 networks from this network. Now, as we know that if we use this class B network, by default it's giving us thousands of network, and we don't need it. We need only one portion of a small portion, that is 11 networks. So why we use this that is giving us a lot, and those all other networks or host addresses will go to waste. So instead of that, what we need, we will do subnet, and that is very easy to do. We will see it now, and we will apply all those rules that we just learned. Now, first of all, the first rule was to identify the IP class. Now, the IP class, as I mentioned before, we need to identify the class by range. What class is this? We know that class B is from 128 to 191. Is this in that range? Yes, definitely. So this is class B. We identify this. This is the rule number one. Rule number two is to identify the network and node ID. Now we know in class B we have two octets of network. This is 172 and 16. These are the network octets, and this is the host octets. Simple and easy. Rule number three was to apply the default subnet mask. Now we know that in class B the default subnet mask is 255.255.0.0. Where we have the network octet, we represent them by 255. Where we have the host octets, we represent them by 00. Now, rule number 4 was to convert the default subnet mask to binary form. Now, this is again easy and simple. We know that whenever we have the network octets, they will represent them by ones, and we have host octets, we represent them by zeros. Now here, each octet is 8-bit, and we represent them with 8 ones and 8 zeros here. This is how the binary form of this subnet mask looks like. Now this is a little bit not complicated, not difficult, but a little bit needs concentration, but we will make it very easy for you here. So this is the rule number 5. What we need to calculate the number, or find a number which is, after calculation, giving us either 11 or bigger than 11. Or let's put it this way, we need to find a number that is, after calculation, it's either equal or greater than 11. So where this charts come into calculation. So for this one, what we need to do, we need to find a number to put in a state of n, or the value for n that is giving us either 11 or greater than 11. So let's see, if we put 2 to the power of 2, it is 4, 4 minus 2, it is 2, so it's smaller. If you put 3 to the power of 3, it is 8, 8 minus 2, 6, it is smaller. So if we put 2 to the power of 4, 4 is 16, 16 minus 2, 14, this is exactly the one that we need. So the value of n is 4. Now, if we calculate the value of n as 4, it's giving us 14 networks. Remember that it's giving us 3 more networks if you think your organization is going to grow in the future, so we definitely go for this. But if you think that your organization even grow more than this, then you can use greater numbers here. That's fine. As long as it is not smaller, you can go with any greater number. It's giving you greater network addresses. But for this example, or for this calculation, I'm just using the 4 because it's more enough for me. Now, what does this mean? This means that now the value of n is 4, and means that I need to borrow 4 bits from the host bits of this IP address to convert it to network. Now this is the new binary form according to the IP rules, that it says to start with ones until you reach zeros. So this means the default CIDR notation for class B is 16, but we borrowed 4, so that is gonna be 20. Now that means we add 20 ones, and then after that we add zeros to complete the 32 bits. Now, where these ones came into place, that is in the third octet. So that means we only need to find the value of the custom subnet mask in the third octet. So here we go where this binary calculator come into the picture to calculate this. Now we have 8 bits and we place them 4 ones and 4 zeros. So 1, 1, 1, 1 and 0, 0, 0. Now in order to calculate the value of this custom subnet mask, we need to add these numbers. So 128 plus 64 plus 32 plus 16, let's see what is the value. So we add them and the value of that is 240. That means the new custom subnet mask for the octet 3, it is 240. Now as we mentioned before, now the CIDR notation for this subnet mask, it is 240 because we borrowed or we converted 4 bits of the host address into network, so that is /20. Now we need to find the LSB. As we mentioned before, the LSB is the smallest bit that still has a value. In this calculation that we have here, which one is the smallest bit that still has value? That is 16. So basically we are not considering the zeros, we only considering the ones. Among the ones, which one has the smallest value but it still has value? Then that is this one, that is 16. So now the 16 is our range and also it is the start of our first subnet. Now let's see how our first subnet looks like. Now our first subnet looks like 172.16, so the start is 16.16.0 and the range means that we add 16 to calculate the next subnet. So 16 plus 16 is 32, so means the next subnet is 32. What is the third subnet? It is 16 plus 32, 48. So this is how we calculate each subnet until we get 11 subnets that we need. Now remember one thing, that 172.16.16 and 32, between 16 to 32 we have 172.16.31.255, so this is our first subnet. And again, the second, the same, between 32 to 48 we have 47.255 and this is our second subnet. And the same here, between 48 48 plus 16 is 64 and between 64 it is 63.55 and that is our third subnet. That was all about subnetting. I hope it was not difficult to understand. I tried my best to make it as easy as possible, but still if you have any questions, concerns and feedbacks, please make sure to write in the comments down below. I try my best to get into each and every questions and answer them. And also please don't forget to share, subscribe and like, so it helps us to grow and also the video reaches more people like you and help them to benefit from these videos. The next class would be on networking devices. I will try my best to cover all the networking devices, but we will start from router and we will discuss everything about routers. So stay tuned. I wish you all the best. Have a great weekend. Bye for now.